Carbon is everywhere, it's the foundation of life and a key player in our planet's biggest challenges. You can't see or smell it, but it's in the air you breathe out, the food you eat, and the materials you use every day. From the plastic in your keyboard to the fabric of your shirt, carbon atoms quietly build the world around us. Today, carbon is often seen as the villain behind global warming, thanks to our release of ancient carbon from coal and oil. But carbon is more than just a problem. It's the lead actor in the story of life and Earth itself. The sugar in your coffee, the gasoline in your car, the wood in your chair, all are forms of carbon. It's the sixth most abundant element in the universe, forged in the hearts of dying stars. Every carbon atom in your body was once part of a star, scattered across the cosmos before becoming part of you. Understanding carbon is a journey through the history of the universe and the essence of life. It's not just chemistry, it's our story. To see why carbon is so special, let's zoom into the atomic level. A carbon atom has 6 protons, 6 neutrons, and 6 electrons. The first shell holds 2 electrons, leaving 4 in the outer shell. These are the valence electrons. Atoms crave a full outer shell, and for carbon that means 8 electrons. With only 4, carbon is perfectly balanced. Neither eager to give nor take electrons. Instead, it shares its 4 valence electrons, forming strong covalent bonds. This sharing makes carbon the ultimate networker of the periodic table. It doesn't steal or surrender electrons, it collaborates. This unique ability to share is why carbon can build such vast and complex molecules. Its atomic structure is the secret to its versatility. Carbon's balance allows it to connect with many elements, including itself. This is the foundation for the diversity of life and materials on Earth. Carbon's atomic dance is the engine of chemistry and biology. Carbon's 4 valence electrons give it a chemical superpower, the ability to form 4 strong covalent bonds. It can link with 4 other atoms, creating stable, 3-dimensional structures. But what truly sets carbon apart is its willingness to bond with itself. Carbon atoms can form long chains, rings, and branching networks, endlessly versatile molecular skeletons. This flexibility is unmatched, even silicon can't compete. Millions of carbon compounds exist, and new ones are discovered every day. Organic chemistry is at its core the study of carbon's creativity. Carbon's molecular magic is why life exists. It builds DNA, proteins, fats, and sugars, the machinery of living cells. No other element offers such a stable, adaptable toolkit for life. Carbon's bonds are the backbone of our world. Diamond is carbon's most dazzling form, a symbol of beauty and strength. Its secret? Each carbon atom bonds to 4 others, forming a rigid 3-dimensional lattice. This structure makes diamond the hardest natural substance, able to cut or scratch anything else. Diamonds are prized in jewelry, but their hardness makes them invaluable in industry for cutting and drilling. In 1796, Smithson Tennant proved diamonds are pure carbon by burning one and finding only carbon dioxide left. Diamonds' tightly bonded electrons make it an excellent insulator and a superb thermal conductor. Today, thin diamond films are used in electronics and medical devices. Born deep within Earth under immense pressure, diamond still inspires science and technology. It's a masterpiece of atomic architecture. If diamond is carbon's hardest form, graphite is its softest and most useful cousin. The lead in your pencil is actually graphite, layers of carbon atoms arranged in flat sheets. Each carbon atom bonds to 3 others, forming strong hexagonal patterns within each sheet. The 4th electron is free to move, making graphite an excellent conductor of electricity. The sheets are stacked loosely, held together by weak forces, so they slide easily, giving graphite its slipperiness. This property makes graphite a great lubricant and the reason it leaves marks on paper. Humans have used graphite for millennia, from ancient drawings to modern industry. In the 18th century, chemists proved graphite, like diamond, is pure carbon. The name graphite comes from the Greek for to write, a nod to its most famous use. Graphite's structure is simple, but its applications are vast. It's carbon's humble workhorse. For years, scientists thought a single layer of graphite, graphene, couldn't exist. In 2004, 2 physicists peeled off a 1-atom-thick sheet using sticky tape, revealing graphene's wonders. Graphene is incredibly strong, flexible, transparent, and conducts electricity better than copper. Roll graphene into a cylinder and you get a carbon nanotube, tiny, ultra-strong, and with unique electrical properties. Nanotubes can act as conductors or semiconductors, making them promising for future electronics. These forms could revolutionize materials, batteries, touchscreens, and medical sensors. Graphene and nanotubes are at the cutting edge of science and technology. Carbon's new forms are shaping the future. In 1985, scientists discovered a new carbon molecule, 60 atoms forming a hollow sphere, like a soccer ball. Named Buckminster fullerene or buckyball, it launched a new branch of chemistry. Fullerenes are the only pure carbon molecules that dissolve in some solvents, and their hollow shape allows them to trap other atoms. They've been found in rocks, meteorites, and even candle soot, nature's hidden architecture. Fullerenes could deliver drugs, improve solar cells, and act as antioxidants. Their discovery earned a Nobel Prize and opened new scientific frontiers. Carbon's creativity keeps surprising us. Beyond its solid forms, carbon's greatest role is as the backbone of life. Remove water from your body, and half of what's left is carbon. It's central to carbohydrates, lipids, proteins, and nucleic acids, the molecules of life. Carbon's ability to form long, stable chains and rings makes life possible. Sugars, starches, and cellulose are all carbon-based, fueling and building living things. Proteins and DNA rely on carbon's versatility to store information and perform countless functions. From bacteria to whales, all life is written in carbon's language. Carbon is the ultimate biological building block. Survey the periodic table, and carbon stands alone in its versatility. It forms the hardest and softest materials, flat sheets, tubes, and spheres. Carbon is both an insulator and a conductor, a master of contrasts. It's the fourth most abundant element in the universe, forged in stars and scattered across space. Our mastery of carbon-shaped civilization, from the Industrial Revolution to today's technology. Now we face the challenge of managing carbon's impact on our climate while unlocking new possibilities with graphene and fullerenes. Carbon is the silent architect of our world, the framework of every cell, and the key to our future. Simple yet endlessly complex, it connects everything from pencils to DNA. Carbon is and will remain the undisputed king of the elements. Its story is our story, written in stardust.